Welcome to the Windows and Composite Materials session of the 2021 Rhode Island Historical Preservation and Heritage Commission Conference. I'm Roberta Randall, and I'm here with Virginia Hesse. We are both historical architects with the Rhode Island Historical Preservation and Heritage Commission. Virginia and I are happy to talk to you today about these subjects. If you have a question at any time during the presentation, please drop them in the Q&A on the right side of your screen. We will try to answer as many questions as we have time for following the presentation. If we don't get to your question, please join us in the open forum following this session. I have a short statement to read. This program is for educational purposes only. Members of public bodies, such as the Historic District Commission, are reminded not to discuss and/or act upon a matter over which public body has supervision, control, jurisdiction, or advisory power. So I'm going to start talking to you first about windows. Oh.
So Roberta, you're going to share your file.
I am trying to do that right now. Thank you.
Okay.
There it is. Okay. So I'm going to start talking to you about windows. And I'm going to start by talking about windows and the standards. Using the Secretary of the Interior standards, all options for retaining historic windows must be considered before reviewing replacements. Standard 5 and Standard 6 both talk about character-defining features that must be preserved and repaired rather than replaced. Windows are character-defining features. Windows are character-defining features on almost all historic buildings, and every effort should be made to keep them. There are several reasons an owner might give for wanting to replace their windows. The most common are thermal performance, lead paint, ease of operation, and minimizing maintenance. Starting with thermal performance can be achieved by keeping the original sash by adding weather stripping, like you see in this picture here, filling any air pockets with insulation, and adding a storm window.
Hi, Roberta. I just wanted to interrupt for a sec to say that you need to get your camera on so people can see you.
Oh, my camera. There it is. Okay.
Perfect. Thank you.
Thank you. Thermal performance can be achieved by keeping the original sash and by adding weather stripping, filling air pockets with insulation, and adding a storm window. A triple track storm window will protect the sash from the elements, therefore cutting down on maintenance. If the look of a triple track is not desired, there are many alternative storm windows on the market, including interior storms like you see here, and what's called invisible storms. These have a small aluminum frame with just panes of glass that go into the openings and have no screens and no muntins. So the next issue is lead paint. Hazards can be mitigated by stripping old paint from the sash and adding a vinyl jam liner. The yellow and blue in the illustration you see here is the jam liner, and that's on the left-hand side. You can see that this prevents the wood from rubbing up against each other and therefore reduces friction and, as a result, lead dust. If you look at the picture on the right, you can see how hidden the jam liner is when the window is closed. Ease of operation can be achieved by either of these two solutions. Both jam liners and weather stripping make the windows operate more easily by eliminating friction caused when wood is rubbing against wood. And the last one, minimizing maintenance, should never be a reason to consider replacement windows. All building parts require maintenance, even replacement windows. So owners must consider the repair option prior to replacing any original fabric, including windows. So when is replacing windows an acceptable alternative? There are some cases when replacement windows are needed. When the original windows are deteriorated beyond repair, when original windows no longer exist, or have been previously replaced with non-historic windows, or when the owner has considered the repair options that we've talked about and for some reason they are not feasible. So what do you consider when you're looking for replacement windows? First, you want to make sure that you preserve as much of the historic material as is possible. So that would include casings, jambs, sills, plaster, clapboard that surround the windows. And secondly, you want to preserve the historic design and the appearance. So you want the new window to look exactly like the window you're replacing. So let's talk about products that are available in the replacement window market and the pros and cons of each. When conditions warrant the replacement of a historic window, there are two ways to replace windows. You can replace the sash and frame. This may not be the best option. Installing new frames in existing openings tends to reduce the size of the sash, makes a replacement in kind difficult. These are two ways to install a replacement sash and frame. The first one, you would remove the entire frame that's there. And when you're doing that, then you have to remove the sills and the casing. You install new frames in place of those. The removed frames, casings, and sills, which are original historic fabric, are lost unnecessarily because in most cases they have not suffered the same deterioration as the sash has suffered. By retaining the original frames, casings, and sills, the material waste that would end up in dumpsters and landfills is reduced, and the risk of damaging other surrounding historic fabric like plaster, clapboards, and decorative moldings is reduced. The second way is to partially leave original frames in place and to provide, which provides structural stability. This will reduce the labor involved and protect the adjacent historic fabric. But because because the old frame is still in place, the new frame and sash needs to fit inside the old frame, so only a smaller sash will fit, which will make the match or a replacement in kind of a historic window pretty impossible. So another better option is to just replace the sash with what's called a sash kit. With this type of replacement window, only the sash is replaced and it is fit into the existing frame using jam liners, which you see in the illustration on the left. Jam liners allow for fitting the sash into what might not be a perfectly square opening and allows for easy operation of the new sash and the preservation of historic materials like the frame, the sill, and the casings. If you look at the window on the right, this is the same illustration we saw before. You can see the jam liner installed, and then when the window's closed, you don't even see it. This is called a concealed jam liner. And what that means is that when the window is closed, the jam liner is completely hidden from sight. There is another kind of a jam liner, which is called a tilt pack sash kit. And just as the name suggests, this type of jam liner allows the sash to tilt in for easy cleaning. In order to do this, the jam liner sticks into the opening and is visible when the window is closed, as you can see here in this illustration. Not only will you see the jam liner, but the sash must be made smaller to allow for the added depth of the jam liner. This loss generally comes out of the pane size, which again makes it impossible for it to be a replacement income. To meet the standards and preserve historic fabric, and to have a window that looks most like a historic window, a sash kit with a concealed jam liner is the best option. So you can get sash replacement in a single glazed, double glazed, or thermopane, or even a triple glazed window. These come in a true divided light, which you can see here in this picture. A true divided light window has separate panes of glass separated from each other by muntins. The historic windows are an example of a true divided light. Some companies make double and triple glazed windows that are true divided light. This window here on the left side is a true divided light window. The glass panes are separate and the muntins go all the way through, and that is a thermopane window. The window on the right is called a simulated divided light window, and it is one large sheet of glass with applied muntins on the exterior and a spacer bar in between the glass. There are sometimes interior muntins as well, as you can see in this picture. The advantage of a true divided light, besides the appearance, is that if a pane breaks, you just need to fix that pane of glass or the muntin surrounding in this case. But it's a small repair, as opposed to when you break a simulated divided light window, as the window on the right there. The whole sash needs to be replaced, because trying to repair that sash is very expensive. You have to take the muntins off, take the glass out. You have to put the gas back into between the panes of glass and the muntins back on, so that they don't do that. You would have to actually get a new sash. There is another kind of grid system, and that's called a sandwich grid. And this is when the grid is placed between panes of glass. There's no exterior muntin or interior muntin. These should never be considered as a match for a historic window. The muntins are hard to see in most lights, and there's no shadow lines that give you the depth of a historic window. So there's lots of materials that historic windows are made from. There's wood, there's vinyl clad, aluminum clad, fiberglass, and fiberglass clad, and probably others as well. Naturally, the preferred replacement would be a wood true divided light sash. A new window can be constructed to look exactly like the window being replaced. There are many window contractors out there that make single glass true divided light wood windows, and these would be a true replacement in kind. There are also manufacturers out there that make wood replacement sash that are simulated divided light, as you can see here. This is an example of a Colby and Colby window. Marvin and Pella also make a good wood replacement. The benefits of wood are its natural beauty, energy efficiency, durability of maintained property, and versatility. Wood windows colors can be easily changed both on the interior and the exterior. Vinyl, although it is the least expensive option, is not a good alternative. Vinyl is not a structural material, and because of that, the windows are generally beefier in order to make them strong. The result is a sash with a heavier parts and less glass. Because of that, it is difficult to achieve a replacement in kind. Besides not being aesthetically pleasing, it is plastic and therefore not environmentally friendly. Does not react well to temperature changes, which causes warping and melting. It cannot be painted, and vinyl fades and cracks over time. Vinyl clad is a better alternative, and that's a wood window with a vinyl cladding or wrap, like you see here in this illustration. It's a better choice than vinyl, but it does have some of the same issues. Vinyl, in general, does not react well to temperature changes, cannot be painted, and may fade and crack over time unless the window is white. Aluminum clad, again, is a better choice than the vinyl because it is structural and recyclable. Although wood is always the best choice, an aluminum clad or an aluminum sash can be made to look like an original sash more easily than vinyl. Aluminum is easily manipulated, so it can be formed to match historic profiles. Aluminum, although it usually comes with a factory finish, can be painted. Unfortunately, aluminum and aluminum-clad windows are the most expensive windows on the market. Fiberglass is becoming a better alternative than any of these for many reasons. It can be painted and it is structural. fiberglass can be formed as a solid. Because it can be formed, it can look exactly like a historic sash. It can also be a fiberglass cladding, like you see in this illustration. Fiberglass is not bothered by water, and because it's inert to moisture, there's no concern about rot, corrosion, mold, or shrinking or swelling. It is temperature stable. Neither heat nor cold will induce fiberglass to flex, sag, or change dimension. That reduces the chance of leaks around the perimeter. The stiffness and strength of fiberglass windows and sashes can be, the stiffness and strength of fiberglass window means that the windows can be narrower and less bulky without compromising their ability to resist high winds. They can therefore replicate a historic sash more easily. The cost is also a plus. Although they are more expensive than vinyl, they are half the cost of aluminum, and they are environmentally friendly and can be recycled. I think that you're all familiar with clad windows, which I've talked about a lot in this portion of the talk. A clad window is basically a wood window with a vinyl, fiberglass, or aluminum wrap around the exterior. So that's similar to the window that you see on the left-hand side here. There are windows on the market that claim to be clad, but are usually vinyl or sometimes aluminum windows with a wood veneer on the inside, which is the window you see on the right. These windows are generally less expensive and not well made. Because of the way they are made, it is difficult for them to replicate the slender profiles of a historic window. So let's talk about details that make up a historic replacement in kind. A typical historic window consists of many parts. This diagram shows the parts and the correct terminology for each part. The window frame consists of parts that we have already talked about. What is most important for our discussion now, since we have discussed that a sash replacement is, in most cases, the best option, is sash parts. A sash is made up of stiles, which are the vertical members of the sash, rails, which are the horizontal members of the sash. You have an upper rail, a bottom rail, and then a meeting rail on each sash that comes together in the middle, as you can see in this diagram. You have muntins and you have glass. All of these parts have a design and a dimension. These are the features to look at when determining if a replacement in kind is actually a replacement. Look first at the overall window. Do the sight lines of the new window match the historic window? Although this may look like a good window, on closer examination, there are differences here that make this not the best replacement in kind. So if you look at the lower rail, you can see that it's a little heftier. If you look at the meeting rails, you can see that they're higher than the meeting rail of the original window and a little heftier. And the glass size itself is shrunk down slightly. So all of those things make this a less than great replacement in kind. But here's an example of a good replacement in kind. If you look at the bottom rail, it matches pretty exactly. The muntins match pretty exactly. The glass size is pretty good. And the stiles and rails all match. The one difference here is the meeting rail. And I will tell you that all window manufacturers say they cannot make a meeting rail that is as slender as a historic meeting rail. It's just the nature of how they make windows now. And for some reason, they say that's impossible to do. So we're always getting windows with a slightly heftier meeting rail. Well, you may not have the benefit of having a manufacturer come out and install a new window next to an old window for you to look at like this. But you can ask for sketches or drawings to scale that will give you the side-by-side comparison of the new window to the old window. And you can ask for those with dimensions so you can see whether the dimensions actually match or they don't. Just a note, since most windows we're looking at are double hung, it is good to know that manufacturers offer double hung replacements as well as what is called a single hung replacement. Single hung replacement should not be considered because they have an added piece at the stile that continues down in front of the lower sash and cuts off the meeting rail. It blocks your view of the lower sash completely. And if you look at the little detail shot in the left-hand corner, you can see that the stile continues down from the top sash to the bottom, and that actually holds the top sash up so it doesn't open, but it also comes down right in front of the lower sash stile. Now let's look at the individual parts. Are the dimensions of the parts the same as the design and dimensions of the historic sash? We'll start with the glass, because if you, in general, pay close attention to keeping the glass size dimensions the way that matches the historic window. So if the glass height and width is the same as the historic window, then you are more likely to get a window with stiles and rails that are similar in dimension as well. When the glass size gets reduced and the pane size gets narrower or shorter, the proportion of height to width changes and the appearance of the overall window changes. And just a note about glass should be clear. Glass should not have any colored tints or reflective coatings. Low E glass is generally okay at the lower levels. When you get to the higher levels of low E, the window takes on a purple tint. Next, look at the muntin. This is a true divided light, as we've talked about before, where there is a wood muntin, in this case, with glass, and then a putty bevel, what's called a putty bevel, that creates a trapezoidal shape. So and all historic windows pretty much look like this. So when you're comparing the muntins on a historic window to a new window, you want to make sure that the new window has this trapezoidal shape to the muntin on the outside. And muntins are generally aluminum or plastic in a new window. So in which case, the dimension should be easy to replicate. It shouldn't be difficult. The muntin width and the muntin depth should be the same as the original window. In a simulated divided light grid, it is important to have the sandwich grid between the panes of glass. So you want to make sure that that bar, that spacer bar, is between the two pieces of glass. This gives you the appearance or more accurate illusion of a true divided light sash when you look at it from the outside. In the manner in which stiles and rails meet the glass is important. It should be a beveled shape to replicate the putty bevel of a historic window, as you can see on the right-hand side. Some replacement sash come with a square edge, which is not a good match for a historic window, as you can see on the left-hand side. It creates an awkward connection between the muntin and the rail. And lastly, when you're looking at window construction, the joint where the stile meets the rail should be a butt joint. Whether the window is all wood or clad, the joint line where the stile and rail intersect should be vertical, not diagonal. I hope that I've provided you with enough information about replacement windows to reach our goal, which is to have the replacement window that is chosen look just like the beautiful historic windows they are replacing. Thank you. I'll turn this over to Virginia now, who will talk to you about composite materials.
Thank you, Roberta. Pull this up. Okay, here we go. Roberta and I have been partners in project review for more than a couple of decades now, and we have had the opportunity to review many substitute materials. I believe this was marketed as composite materials, but we'll look at both. So the original materials we typically get requests for replacing is wood, slate roofs, but sometimes also masonry or other components. But most substitute materials and composite materials are made in a lab. There's no end to the introduction of new synthetic products claiming to be superior, maintenance-free, more rot-resistant, as beautiful as the natural building material. But in fact, none of these have been around long enough to really substantiate those claims. So we have to evaluate the material both visually, but also performance. So let's look at some evaluation criteria. What is the need for replacing this historic fabric? First of all, I think it's fair to ask a property owner why they think they need to replace it and who's advising them on replacing it with this new material. If it's a contractor, it could be, trying to sell a product. But there are deteriorated features of historic buildings that legitimately need to be repaired. So has the product performed poorly? Is the original material no longer available? Are the craftspeople or tradesmen not available to replicate the work? Or current codes will not permit use of original material? That might be something like asbestos containing products or lead coated products. You should also evaluate the quantity and location of the material that they're proposing to replace. Is it on a character defining facade? Is it a character defining feature? Is it high up on the building, on a multi-story building where it's harder to see, but also where it's harder to maintain? Or is it in close contact with the ground where moisture is an issue? Or is it in the back of the building where no one will ever see it? Visual qualities, really, how close a match does it appear to be? Look at the design, the color, especially variations in color and aggregate across the material. The dimension, surface and thickness, surface texture, profile, reflectivity, and finish. And finally, consider the performance of the material. Has it been around long enough to prove that it will weather well over time? What about the density and texture, the rate of thermal expansion and contraction, rate of vapor permeability? How will it age and wear? Color retention, will it fade? That's a big problem with many of these products. And the strength, is the new product as strong as wood? We saw in windows where vinyl cannot reproduce a wood member because it's not strong enough. So some of the materials we're often asked to substitute: PVC, for example, Trex is a product that you've all heard of for wood decking, cast stone for natural stone, vinyl and plastic or PVC, such as ASIC for wood and metal replacement, rubber and PVC for slate roofing, fiberglass or FRP for stone, wood, metal, ornament, and trim replacement, IFIS for dry-vit or dry-vit, as you may know it, for natural stucco replacement, and cement board siding for wood siding. We'll look at some of these, not all of them. In my personal opinion, there are very few substitute materials that are a close visual match for natural materials and which also behave in the same way in terms of expansion and contraction, weathering, strength, and color retention. So let's evaluate PVC trim, since that seems to be the most popular thing to use these days. Flat board PVC trim can match the appearance of painted flat wood trim. It's a low bar, it's easy to match, and it can be done. Unless it is painted a light color or just plain white, the PVC will absorb heat and expand and contract to a greater degree than wood. It is better used in higher locations, which are more difficult to reach, to paint or repair, and also to see, and where it also comes in direct contact with the ground, such as skirt boards and plinth blocks. It should always have a smooth finish and never a raised wood grain finish. It is not ideal for replacing historic porch railings unless the original spacing can be replicated. And I have an example of why that's the case. But first, this is just an illustration of how long boards of running trim can separate because of the expansion and contraction issue, and gaps often do open up in that kind of situation. And with porch parts, this is a perfect illustration. On the left is a wooden roof railing that was supposed to be replicated by the applicant, the developer. And unbeknownst to us, they chose to do it with vinyl, and not only white vinyl, green vinyl, which compounds the problem of the strength of material, because the darker color absorbs more heat and is a weaker material. So what they did was they had to reduce the spacing between posts that you see on the left, and they also could not have the long continuous top rail because the material couldn't do that. It would have been floppy. So they had these little posts come up through the top rail so they could have lots of short little lengths of railing. And as a result, the new railing looks nothing like the old railing. So it's because of the nature of the vinyl material that could not replicate the original porch. Slate roof shingles were also often asked to replace those with either rubber or asphalt. But the nature of real slate is it has a variety of color and texture within the natural material. You can see on the left where the color has changed over time, so it's not a uniform color. Not every single slate is quite exactly the same. There are different edge profiles, but most rubber slate products are limited sizes. They are also a very uniform color. You can get different colors, but across the product line, it's very uniform. So here's a natural slate next to a slate of rubber slate, and actually they do look sort of similar in texture and edge profile, but the color is just poured into a mold, and it's one flat color. In evaluating these new slates, natural slate has a color variation across the shingle and between shingles from one to the next, which will further weather over time. Weathering slate changes color, resulting in a patina of subtle color variations. Rubber slate will not do that. Rubber slates are poured into a mold and are uniform throughout. And they're also uniform in size. Not all slates are the same size. From roof to roof, they could be very different in size. Some are wide, some are narrow slates. The slates the rubber slates tend to be a very narrow size range, so you might not even be able to match the size. And they tend to cup over time. Here's some examples that you can see. The two slate roofs on the left have different thickness from slate to slate, both in width and in edge profile, and obviously different colors from slate to slate. The picture in the middle shows a rubber slate roof that has started to cup, but there's a uniformity about it that you don't see in the natural slate roof. And the same with the picture in the lower right corner, extremely uniform, no variation in thickness or color. And then there's the asphalt slate, which has no thickness whatsoever, but they try to achieve that effect with the shadow line between and below each shingle. But again, they're all very uniform in size. They have a granular texture, which gives them their color, but that doesn't match a slate, which has a smooth finish and a sheen to it, and there's no graininess to it. And these granules will actually weather off over time, so who knows what it will end up looking like. But the result is that it doesn't really replicate a slate roof. Cement board siding. There are appropriate applications for cement board siding, but there are also physical limitations that result in a very basic change that you should be aware of. So in the two pictures of the windows on the left and the right are historic windows with an appropriate relationship of lapped siding to trim, which has the window trim standing proud, and you can actually see the edge of the window frame sticking out. But the cement board siding is overall a thicker application, so it comes out flush with the face of the trim, and it flattens out the facade in the big picture. So here's why that happens. The black vertical line on the left is the profile of a cement board piece of siding, and it can't taper like a cedar shingle because it's a brittle material. So if it tapered, it would snap off at the narrowest part. So consequently, it's uniform shape. The cedar clapboard on the right is tapered at the top and actually has a wider butt than the cement shingle at the bottom, so that there are two changes there. One is the overall thickness of the lap when you're lapping something that doesn't taper, but also the cedar clapboard has a heavier butt, so it creates more of a shadow line. So on the far right, you can see that the leading edge of that cement board comes up flush with the casing, with the red casing. So you lose the shadow line that we have here. So on the picture that on the left, the historic window has a robust shadow line on the right and underneath the sill. But in the picture on the right, where the cement board comes up flush, it reduces all the shadow lines and the complexity that gives a historic facade its richness and text. So where is it appropriate to use it? Narrow alleyways where access is limited for routine maintenance and where the sun doesn't reach for drying it out, where there could be a potential for mold. Also where fire prevention is a factor, such as where houses are this close together in this alleyway. It is more fire resistant than wood, obviously. On rear facades away from public view, if there's a deterioration problem with the original siding and for whatever reason it can't be replaced in kind with wood. But where it's used, the trim ideally would be built out to retain the proper relationship of the lap siding to the window trim. And remember, smooth texture only, please. This is just a case study of where some composite materials were used to replicate historic features. You're all familiar with the Ocean House and how it was reconstructed. And our office was involved. We had a memorandum of agreement with the developer to help them rebuild the building so that it looked as close as possible to the original building. So some of the compromises had to do with cement board siding. So they used the cement board siding. Their insurance company wanted them to use it because of the fireproof quality of the material. So the compromise was that they used it above the porches, further away from public view, and under the porches where people walked close to the building. They used wood siding, wood trim, and everything was authentic. And the other place that they used composite materials were on the porch parts. They replicated the balusters in ASIC material. They were able to turn them and replicate them exactly, even to the original historic height. And they met code by just adding the simple metal railing on top, which you can barely see. And the columns were fiberglass, because that building is exposed to such harsh weather that they really needed something that was going to stand up to that over time. And I have to include this. We don't see many applications for this. HDC members may see it, but we don't recommend this as a substitute for wood. It doesn't appear, it doesn't look like wood, doesn't weather like wood, and it will warp over time. It may fade, we don't know. It just is a relatively new material. And then the last material that I'll talk about is fiber reinforced polymer, or FRP. It's a version of fiberglass and is a proven material used for replacement of lost or extensively damaged architectural ornaments. It could be molded into any shape for precise replication. It is moisture and rot resistant and impervious to water. It is extremely strong. It is not subject to thermal expansion, and it has good paint retention. Sounds good, doesn't it? Here, I want to show you this example of where it was used, and it's holding up really well. The old Providence Journal building on Westminster Street downtown was restored in mid-1980s, and a lot of the original ornament had been damaged or destroyed, and they were able to replicate it with fiberglass. And a recent examination of the building within the last 2 years excuse me, showed that the fiberglass is still in really good shape. So that was great to hear. But it is not the perfect material. It is good for replacing architectural ornaments such as medallions, finials, friezes, and brackets, cornice moldings, replacing wood or metal if it's a particularly ornate cornice, because it is a much more expensive material than wood. Storefront columns, if it has to replace cast iron columns that might be missing, and porch components such as columns, newels, and balusters, because it is a much stronger material than vinyl. But this is an example where it was used with mixed results. The Cranston Street Armory has a balcony way up on the top of that tower that had to be removed because it was falling off. Unfortunately, it was saved, and it was replicated in FRP, as you see it in the picture in the middle. And it actually came out pretty well and held up pretty well in terms of structure, and it was a lighter material than the masonry. But the problem was, you can only pour it into a mold in one color, and the rest of it had to be hand painted to replicate the brick and the other features. And that paint faded very quickly. And that was the result, the faded balcony. So it was removed, and they rebuilt the original and put it up with this extra support. And that is the story of the FRP. So just to quickly wrap up, please never, never, never raised grain. It's a sandblast effect, and wood does not look like that naturally, whatever they tell you. And the evaluating criteria you should consider: the need for replacement. Always, always, always repair or replace in kind before considering alternative. Quantity and location, visual qualities, and performance. And I've talked long enough. So if I've run into our Q&A session, here are emails. If you have any questions, please feel free to email either of us over the next few days. Thank you.
Great. If anybody has any questions, or Ginger and Roberta have put some in the chat for you to see.
Ginger, there was a question in there for you.
So I can read it if that helps.
Okay, so, that would help, please.
Sure. Ross Ann had asked if we were looking at Belcourt, and also wanted to know if you have looked at porcelain slates, which are more varied and true to life.
We have not, but there was a short period of time where cement shingles were used in place of slate, and they proved to be very brittle, and that was a very short-lived experiment. So I don't know how porcelain would fare, but I'm sure they could do a fine job of replicating the appearance. So send me information. We're always open to new ideas. And no, we're not. Sadly, we're not involved in Belcourt.
And Elaine Trench had asked about going back to your summary slide. If it's possible to reshare. I mean, we've only got a couple more minutes.
Well, can you explain that these are recorded so they can play them back at a later time?
Yeah, absolutely. And you can share these with, oh, excuse me. You can go back anytime in the next 30 days to rewatch these sessions. So we weren't looking at Belcourt. Could you tell us what building we were looking at when Ross pinned it as Belcourt Castle?
Oh, I thought he asked if we were involved in Belcourt. Maybe I misunderstood.
And a couple more questions from Kay Graybiel. Have you reviewed renewal windows by Anderson with wood structure and vinyl exterior?
Roberta, you want to take that?
I don't know that we have specifically looked at that window, but we have looked at wood stash with vinyl cladding that have been approved. So we have, and they may have very well been that window.
All right. Well, that question, I think we're going to wrap up because we'll cut out right at 4. So thanks everybody for joining us. Do you have any conclusion?
Well,